So I send out this homework. Thank you for both of you work on the homework. I just want to quickly check. Okay, I want to just make sure, see if this foundation is ready. Okay, Jason.
Yes.
Let's see number 16. You want to try the distribution property. Go ahead, please.
All right. -2 times 7.
You are going to do this guy times this guy and then do this. Okay, go ahead.
Okay, so -2 times 7 is -14, and -2 times n or -n. I'm actually not so sure.
-2 times -n. Negative times negative is positive. So you will have a plus 2n.
+2 plus 4.
Plus 2n, okay? This as a variable, so you will carry on this, and then you plus 4.
Okay, makes sense.
Next step. Next step, continue, please.
Oh, okay. So
you can combine this. Go ahead.
Yeah. So 14 plus, you know what? Okay, -14 plus 4 is -10.
Yes, perfect. Very good. -10 plus 2n. Very good. I do see that you know how to do distribution property. And you can also do the negative number plus positive number. Very good. Next one, Ian. Let me check you for number 20. Go ahead, please.
-7 times k is -7k. Subtract -56.
Very good. So we can write down on the side, negative times negative equals
positive.
Positive. Very good. Plus 56 and then plus 2k. Let's combine the like terms. Go ahead, please.
So -7k plus 2k is -5k plus 56.
Very good. Yes. All right. Yeah. Since you both do very well, we can do quickly. So those easy questions. Okay. Let's check one more. Jason.
Okay.
Number 9. Number 9.
Okay.
Please.
So -6 times 1 is -6.
Good.
And -6 times positive 11b is -66.
Very good. All right. Now, Ian, let's do 15, please.
So what did I do? -15 times 7 is -105.
Very good. That's good. Number sense is good.
And then 15 times 19b is
let's try here. Go ahead.
Is so 9 times 5 is 45. Carry to 4.
Okay, so what number you put here?
99.
9. Good job. And then next layer.
And then it's 19.
Good.
19.
Next.
And then you add it, so it's 285.
Very good. So here you write down as
-285b.
All right. I see that the foundation here is pretty good. Let me make sure. See this kind of thing. Okay, let's see here. Do those fractions. Okay, let's try. Jason, how do I do this fraction?
Okay, so 1.67, 7 times 1 plus 6 is 13 over 7.
So
then,
13 over 7, right?
Yeah, and then 5 is 3/4 in the improper fraction. 4 times 5 is 23/4. But
Very good.
when you divide it, you actually multiply, but then on the second fraction you switch places.
Very good. So you times the reciprocal of this guy.
Yeah.
This is
4
good.
times
So, yeah.
13 times 4 is 32. 23 times 7 is.
So it's all downstairs.
Yeah. Try using your mental math. Give a try.
Oh, it's 3 times
7 times 3 is
21.
Mm-hmm.
And then 7 times 2 is 14 plus
Yes.
2 is 16. So
There you go.
161.
Beautiful. I like it. Very good. Then let's do this one.
Okay, so you have -3 times 10 is -30 plus 7 is -23.
Hold on.
-37 over
Yes.
10. Over 10.
Let's make this part clear, okay? This guy, by default, you have a parenthesis to protect this. So this is saying you have -3 plus 7 over 10. And this is -37 over 10, okay? Yeah, don't confuse this, think this way. This is not saying -3 plus +7 over 10. This is wrong, okay? This is wrong.
Okay, so
Let's continue.
-37 over 10 divided by 4 times 2, which is 8, plus 1 equals 9. So 4,
Good.
9 over 4. And then you need to flip it. So it's
Sure.
-37 over 10 times 4 nines.
Good.
And then
Before we do the next step, I don't want to do 90 and do this. If you can simplify, do it as early as possible.
Yeah.
When you see this number even, divide it both by 2. Let's go ahead.
so the 4 will become 2 because
Good.
and then the 10 will be a 5 because divided by 2.
Very good.
So and
Next.
then it would be 5 times 9 is 45. So 45 is the denominator.
Mm-hmm.
And 37 times 2 is 74.
Good. All right, I think, yeah, based on what I see right now, both of you do pretty good. Since the arithmetic part and the algebra expression part, both good. Let me see here. Factoring, okay, factoring. Jason, let's try number 7.
What?
Look at this. They want you to do this guy divided by 9. I don't know if your elementary school teacher teach you this or not. I need to teach some foundation
They teach
for
long
number
division,
sense.
but definitely not mental math long division. Although
Okay,
I can do it quickly.
It's okay. Let me show you something. When you see a number like this, how do you know if this number is divisible by 9? What I mean divisible means if you do this guy divided by 9, how do you know the remainder is 0? How can you tell? Here is a trick, okay? If you see here, if this guy plus this guy plus this guy, how much?
18.
Yeah, 18. If this guy is divisible by 9, then this number will be divisible by 9. It's always true, yeah?
Yeah.
For example, if I write down 3, 3, 3, I know this 3 number plus together divisible by 9.
Yes.
This number will be divisible by 9. Okay?
Okay.
Okay? Yeah. I will, right now, both of you haven't learned algebra yet. By the time I teach you both algebra, I'm going to prove to you to see why this is always true. Okay? Right now, we just use this kind of trick.
Okay.
Let's go ahead. Go ahead.
684 divided by 9.
Mhm.
Not 9 times 7 is 63. The
Okay.
closest number without exceeding the number.
Sure.
8 minus 3 is 5. 6 minus 6 is 0, 54. And then 6. 70.
Good.
6 times 9 is 54.
Perfect.
54 minus 54 is 0.
Yeah, that's good. Okay. Aaron, let's do this one.
Okay.
Based on what we learned just now, how do you tell if this guy is divisible by 9?
If you add up all of the digits. So
Sure.
13 plus 7 is 20.
Oh, let's see if this is true. Okay. Go ahead.
Okay. So a 9 times 8 is 72. So, and then 76 subtract 72 is 3. And then you bring down the 7. Wait, no, I mean 4, not 3, sorry. And then you
Okay.
bring down the 7. And 9 times 5 is 45.
Yes.
And
Oh,
then
you have a remainder.
remainder.
Why? Because when you sum the digits number together, it's not divisible by 9. So this number is not going to be divisible by 9. Okay? Now, I want to show one more trick. Listen. Let's do 11.
Okay.
If you want to see a number is divisible by 6, you do it by this way.
Seven-
You first say 7 plus 0 plus 8.
Yeah, I know that.
Oh, you know this. Good.
7 plus
15.
0 plus 8 is 15. And that is not divisible by 6.
Hey, hold on. This is different. Divisible by 9, you plus them together. If this number is divisible by 9, this will be divisible by 9. Divisible by 6, you are not going to do this guy divided by 6. It's
Okay.
different. Okay, let me finish my statement.
Sorry.
15 is divisible by 3, correct?
Yes.
15 is divisible by 3. So if those numbers plus together is divisible by 3, this guy will be divisible by 3. And at the same time, if you are an even number, it's going to be divisible by 2. So divisible by 3 and divisible by 2, that means you will be divisible by 6.
Makes a lot of sense, actually.
Does this make sense?
Yes.
All right. Now let's verify. Let's check. Go ahead.
Okay. The first one is 1 times 6 is 6. 7 minus 6 is 1. Add the 0, it's 10. And then do another one. 10 minus 6 is 4. Add the 8. Put on the 8. 8 times 6 is 48.
Good.
So 48 minus 48 is 0.
Oh, okay. So if you want to tell a number is divisible by 6, you want to add them together to check if it's divisible by 3. And then you can tell this is even. So it's going to be divisible by 2. So for example, how do you tell if a number is divisible by 18? Look, this one. This one, I can tell this guy is divisible by 18. Why? First, divisible by 9. Second, even number. So this number will be divisible by 18. Make sense? Does this make sense? Jason, does this make sense?
Yeah.
Okay. Aaron, do you have any question for what we practice over here and here?
No.
The reason we are talking about the factor is because in Algebra 1, by the time you learn Algebra 1, it's going to use this factoring skills a lot, okay? Yeah. Next one. All right, here, look at number 20. Tell me this guy is divisible by what? Look for the factor for this guy.
5.
Good. If you have a 0.
And 10.
If you have a 0 or 5 at the end, it's going to be divisible by 5. If you have 0 at the end, it's going to be divisible by 10. So this will be 10 times what?
41.
41. Do you remember 41 is a prime number or not?
Prime.
Yes, very good. This guy is a prime number. Okay. Let me check you for 256. 256 is what kind of factor could this guy have? Can you give a try? Go ahead, Aaron. $256. First, it is divisible by 2 for sure, correct? So far, so good. Let's try 2. Give it a try. 2 times who?
2 times.
You see, 2 over 2, you put 1.
148.
Hey, hold on. This is 200, so divide by 2 is 100 over here. And the last 2 digits is going to be 56 over 2, which is 28, correct?
Yes.
All right, so we want to put 128, okay? Who is 128?
148 is a composite.
2, yes, 2 times who?
2 times 64.
Good job. 2 times 64. 2 times 64. Continue. 64 is who?
32.
64, as you can imagine, is 8 square, correct? Yes. 8 times 8 is 64. Yes?
Yes.
Okay. 8 is who?
2 times 4. Or 2
8
to the 4.
is 2 times 2 times 2, correct?
Yeah.
Right. So look, I want to introduce something called the power, okay? This power is saying 256. You can rewrite this guy by 2 to the power you see here, okay? If I write down all of the 2 together, there are 3 2, and then square. This means you have 2 2 2, and then another 3 of 2. You see? This guy is 8. This guy is 8. And then 8 squared is 64. 64 times 4 equals to 256. So how many 2 here? Let's count. Count with me together.
5, 8.
8. 2 to the power of 8. Okay? Let me introduce something very interesting. Most boys are very interested about computer science. So possibly you might take computer science course during middle school. and some AP computer science in high school. Computer science are all based on the binary numbers, either 0 or 1, okay? Either 0 or 1, it's binary. So when they represent the numbers, they do this way. For example, if you want to say 5, you don't write down 5. You need to write down this as 4 plus 1. And 4 is 2 to the power 2. 1 is 2 to the power 0. So if you change this to a binary format, the first digits, this means 0. The second one means 2, and then 4. And then, so 0 digits, you have 1 here, and then here, and here. So in the binary format, okay, this 5 can be represented by 101, okay? Yeah, you will learn this kind of thing when you start to learn computer science. So, I would like both of you, yeah, because I can tell you both are very advanced students. So I would like to introduce this. Let's start to remember all those 2 to the power, okay? Let's see. 2 to the power 0 is 1, because look, 2 over 2 is 1. That means 2 to the power 0. And then 2 to the power 1 is 2. Jason. Yeah, when I write down the bottom, tell me the number above. Go ahead. This guy?
Mm-hmm. Two.
This is 8.
8.
Correct? Mm-hmm.
That's 8.
Next.
Okay, so next one is 16.
Mm-hmm.
32.
Good. Continue.
64.
Yes.
128.
Continue. There you go. Continue.
256.
256. Next.
512.
Very good. Next one.
1024.
Okay.
2048.
We can remember up to here. Okay. So next time when we see this number, we immediately can relate this guy to 2 to the power of 8. Okay. You know, we always talk about, I need 1 gigabytes. 1 gigabytes means what? Here, 2 to the power 10 is 1,000 bytes. 2 to the power 20 is 1 megabytes. And 2 to the power 30 is 1 G. Okay, that's what we're talking about, those kind of like data amount. Okay. Yeah. This is about those factorings. Now we want to look for those least common multiples and greatest common factors. Okay. Now, let's see number 9. Ian, let's do number 9. Go ahead. You see these two. Are they both divisible by 2?
Yes.
This guy divided by 2 will be how much?
34.
This guy is 34 times 2. This guy is 34 times 1. Make sense?
Yeah.
Okay. So when you see this pattern, what do you think? Who is the greatest common factor? Greatest common factor for these two numbers is going to be this guy, because 34 is the largest common factor for these two. And you say, why you don't choose 2? Because 34 is 17 times 2. Okay, yes, 2 is a common factor. 2 is a common factor. But 2 is not the largest one. You are looking for the largest common factor. So you see 17 is another common factor.
Oh, I get it now. I forgot. Oh,
So 34 is the greatest one. Yeah? G, C, F. Okay? Yeah. The reason we review this is because this is an important part for pre-algebra. Okay? So I'm going to ask you a little bit more challenge question. Previously, we are just dealing with the number. Now we have to deal with the variables. Okay? Let's see here. I will guide you through. Okay? 66 is what?
3 times 22. 3 times 2 times 11.
Good. And then y and x, we can write down x and y. Okay? In elementary school, we write down multiplication this way. We write, say, 3 times 2. But starting from middle school, we don't write down multiplication this way because this guy looks so similar as x. So if we continue using this as the multiplication, we will get confused. We don't know this is a multiplication or this guy is an x. So starting from middle school, we use the dot product. We say 3 times 2 times x. This is going to be 6x. Do I have to put the dot here? Not really. 6x is same as 6.x. Okay? Does this make sense? But if you say, can I say 3 times 2, just write down as no? No, you cannot. If it's 2 numbers, if you want to show its multiplication, then you have to put a dot between. Does this make sense?
Yes.
This guy does not equal this. Okay, 32 is 32. Yeah. Okay, all right. So you finish this pattern. Let's go this way. Go down.
2 times 3 times 5.
2 times 3 times 5. X squared. Let's make it x times x times y. Okay, so we are going to do the greatest common factor. We don't rush. We are going to look for the common one first.
There's a 2 and a 3.
3 are the same. You can highlight. 2 are the same. You can highlight. What else you want to highlight?
Y.
Good. Who else?
X.
You can also highlight x. Then we can extract that guy. So the greatest common factor is 6. Go ahead.
6xy.
6xy, perfect job. Very good, you get it. Does this make sense to you now?
Yeah.
Okay. Let's try one more, okay? Jason, you can try 15. Let's go ahead.
All right. So 18 is 2 times 3 times 3.
2 times 3 times 3. Okay.
54 is 2 times 3.
Well, let's also put the y also.
All right. Times y.
Times y.
Times y.
Okay. Now let's do this one.
2 times 3 times 3 times 3
Yes,
times y times y.
very good. Now let's do the common factor. Which one you want to highlight?
3.
Next,
2
next,
y.
continue. Continue.
3 and y.
Okay, there you go. So that guy, right? Yes. You
Yeah.
are looking for the one who are in common, you know?
Yeah.
Right?
Mhm.
You cannot pick this one because this guy does not have mole 3. You cannot pick this one. You have to pick the one who happens in both. Okay, that's a way to look for the common factor. And then you get them. Product is the greatest common factor. Go ahead, say the answer, please.
3
Go ahead.
y.
Okay,
3 times y.
all of this times together. This times together equals how much?
18.
Yes. Y times y is
2y.
hold on. This is the thing I need to
Y was the exponent of 2.
look. Y plus y. This is called combine the like terms. This is 2y. Watch out here, okay?
Okay.
Y times y is y to the power of 2. Okay? So let me show you. What does square mean?
Yeah, I actually know it. It was just a mistake.
It's okay. So the definition of square can be explained like this. If I tell you the side is y and y, and this is the perfect square, the area is going to be y squared. Does this make sense?
Yes.
If you have a cube, if you have a 3D cube, okay?
Mm-hmm.
If you have a 3D cube, if every side is y and y and y, then the volume of this guy will be y to the power 3.
3.
That's called y squared. That's called y cube. Does this make sense?
Yes.
Good.
So we got 18 y cubed.
Wait, y squared.
Y square meant.
Here is y
Y
squared.
square. Y square.
Oh, that's it. That's it, okay? Does this make sense to you now?
Yes.
All right. Now, the other student, go ahead. Next one, 16.
So it's 2 times 2 times 2.
I show you a trick, okay? When I see 0, 0, I'm going to take the 10 out. Can we? Does that make sense?
Yeah.
If you have a 0, 0, oh, maybe it's going to be easy. 8 times 10. Oh, I cannot use x. It's going to be confused. So 10 times 8, x cubed, x, x, x. Does this make sense?
Yeah.
Next one.
3 times
10 times 3, right?
2 times 3 times y times x times x.
Okay. X, x, x together is x cubed. X times x is x squared. Now go ahead, tell me those common factors.
The 10.
10, can you highlight?
Yeah.
Who else?
The x. The other x. Yeah, that's
That's
it.
all.
10 times x to the third.
Hey, hold on. Look,
X
this
squared.
guy is in common. This guy is common. So this greatest common factor is
10 times x times x.
10x squared, right? Yes. Does this make sense to you now?
Yes.
All right. Next student, let's do 17. Oh, this time, 3 terms. 3 terms. No rush, no panic. Let's settle down this way. 505. Which number you want to use? Go ahead.
0,
Mm,
5.
you have 5 or 0 or 5 on your last digit. You want to try 5, okay?
5.
5 times. Hold on. Did I say this guy? This is divisible by 3, so this guy will be divisible by 3. Yes?
Yeah. Yes.
So I'm going to do 5 times 3 times what? Look, 105 is 5 times 21. 21 is
7.
3 times 7. There you go. Now let's do 30. Go ahead.
30. Okay. 2 times 5 times 3. And then times y and times x.
Very good. 75. Go ahead.
2. No, let me think.
5 times.
5 times.
Let me show you.
15.
Let me show both of you a trick. Okay. If you want to do 75 over 5, if you feel doing this is a little bit slower, let's do this. We can times 2 for top and bottom. 75 times 2 is 150, right?
Yes.
5 times 2 is 10. So this is 15, you know? So every time when I divide by a 5, I just times by 2 and I get rid of 0. I can figure out in my mental math. Okay?
Okay. So it's times
So,
15.
yeah, 15 is who? 15 is 3 times 5, right?
20 times 5.
Go ahead.
3. So it's 3 times 5 times 5 times x.
There you go. Now let's highlight the common one. Go ahead, please. 5.
5.
Don't draw 2 of them. Just draw 1 of them. Okay?
Yeah. Okay. 3.
Next.
3.
Good. Next.
X.
There you go. So GCF is
15 times x.
awesome. There you go. Good job. Next one. Oh, this looks a little bit complicated. Let's go. The other student, take turn. Go ahead.
Okay.
When
so
they all have 0, what are we going to do?
Cancel the 0, so it's 14, 14, and 8.
14 times 10. So we can do 10 times 14. We want to do 2 by 7. Can we, please?
Yeah.
Go ahead.
Times n.
Next.
And then 10 times 7 times 2 times n.
Times what?
M times m.
Good. Last one, please.
8 times 2 times 4.
Yeah, we can do that. That's fine. Times?
M times m.
Okay, now let's highlight, okay? Which
Okay.
one you want to?
The 10.
There you go. Next. You have to look for those common ones, okay?
It's the 2. The
2, right? 2, 2, 2. Next.
And then the m.
This is the same. You see, this guy has MM. This guy has MM. This guy. Does this guy include MM? No. Yeah. If the one term does not have that MM, you cannot include this in your greatest common factor. Yeah? I feel sorry for this guy. Yeah, this guy does not have this, but you cannot put MM. That's it.
So it's 70. No,
yes,
20.
No, 20.
Sorry, 20.
Yeah. Okay. All right. That's about common factor. Now we are going to do a little bit complicated about least common multiples. What is least common multiples? What's the definition of that guy? So let's see here. 10 and 3. You see 10 and 3, okay? Here. If you times 10 by 2, that's 20. If you times 10 by 3, that's 30. Next, you are going to do the multiple times of 3. You times by 2, by 3, 12, 15, and you continue going until you reach to a 30. Oh, you go so many steps, and this guy just go 2 steps. This guy you share. That's your least common multiple. And you say, teacher, if I go to 60, this guy go to 60. This guy is also a common multiple. Why you don't choose 60? You are looking for the least one. 30, 60, 90, so on and so forth. Yeah, it's all called a common multiple, but not the least one. So the least one is 30. Okay. Next, Jason.
Okay.
Let's look for number 5. Let's see who is a common multiple for this one.
27, 54.
Let's try this way.
81.
18 times 2 is how much?
36.
Next. 18 times 3 equals? 18 times 3 equals?
54.
Yes. There you go. Does this make sense?
Yeah.
Okay. Now I'm going to teach you a trick. Okay. Each time if you continue writing down is kind of slow. So there is a formula. Look, least common multiple is defined by these two guys' product divided by the greatest common factor. That means as long as you can find the greatest common factor, you will be able to find your least common multiples. Okay?
Okay.
Students, if any question you feel confused or you think I teach too fast, you use the chat window, send a message to me, okay? And I'm going to help you, okay? Now, look at this. Let's look this way to figure out. Right now, yes, we can get 54. We want to try the other way. What's the greatest common factor for these two numbers? Jason.
All right. So 27 is 2. Hold up. Okay, 3 times 3 times 3.
Yes.
18 is 3 times 3 times 2.
Very good.
And we got 3 as common factors, but
Okay.
only 3.
Yes. So
Greatest common factor is 3 times 3 is 9.
yes. So 3 times 3 is 9. And these two guys' product, we do 27 times 18 over the greatest common factor. That's going to be the least common multiple. We don't want to do this product first. It's too slow. Let's simplify here now. 27 over 9 is how much?
So it's going to be 3 and 1. 3 is going to be 27. 9, 1 is going to be over 9.
So 3 times 18 equals?
54.
There you go. You see? You don't need to write down so many. You can use this way. Okay? Now I'm going to teach an even better way. Watch out here. Look. We found this guy. Yes?
Yes.
So this
Yes,
guy is a common one. Take it out. Take it out. And then this guy and this guy, they are those single factor by themselves, not common factor.
Yeah.
That's it. Hey, hold on. There. Correct?
Yes.
Does this make sense to you?
Yeah.
You like this way of finding the least common factor, the greatest common factor, and then using this way to do the least common multiple? Do you like this way?
I actually do, but I'm going to test out the two faster ones, see which one is easier for me.
Yes. Very
or more effective.
Okay.
And then
Very
I'll
good.
make my decision.
Sure. Now let's do number 10. Yeah. Sorry, can you repeat your name one more time? This is the first time I see this name, so I have trouble to pronounce it correctly. Say one more time, please.
Ian.
Ian. Okay, Ian. Ian, let's do number 10.
Okay, so 35 is 5 times 7. And then 25 is 5 times 5.
Okay.
And then the 5s are equal, so it's...
We take 5 out, and then?
5 times 5 times 7.
Yes. 5 is the common one. So we just write down 1 of 5. And then this guy times this guy. Make sense? Yes. And does this make sense to you?
Yes.
Let's figure out how much is here.
5 times 7. 175.
Good job, you made it. That's nice. If we don't do this way, we use the other way, it's going to be very slow. We have to do what? Oh, this guy, 70, 105, 140. We have to keep going, right? Yes, I think this way is good. Okay, let's keep drilling these skills. Jason,
Yes.
let's see this guy. Go ahead, please.
Okay, so 18 times, so 18 is 2 times 3 times 3 times 3 times x times y squared.
Yeah, we can just write down y times y, okay? Now let's do the other one. Go ahead.
So 15 is 3 times 5. And then y cubed.
Y and y and y, okay?
Yeah.
Now go ahead, take the common factor.
3. Y.
Correct? So far, so good.
Yeah.
GCF is
3 times y squared.
good job. Now, this guy has 2 and 3 and x left. This guy has 5 and the y left. So let's times them together. 3y squared times, this is 6x, right?
Yeah, 6x
Times
times y. 5 times 5y.
there you go. Equals
Okay. So 18. No, hold up. So 3.
you do this first. You do this first. 6
Okay.
times 5
30.
is
30.
yes.
And then x times y is xy.
Okay, hold on. This is 30 times 3 is
Yeah.
90, right?
90. Yes.
90. And
Y times y squared is y cubed, right?
there you go. Yes, very good.
And then x, just x.
There you go. Oh, perfect. Good job. I like it. Thank you. Very nice. Now, and let's try number 12. Okay. This. Let's go ahead. This. Yeah, that's fine. Let's go ahead to this one. Go ahead, please.
For 20, it's 2 times 10.
10. That's further factor. One more step.
2 times 5 times, wait, 2 times 2 times 5.
Good job.
Times x times x times x.
Okay, very good.
And
Let's do the other one.
16 is 2 times 2 times 2 times 2. And times x times x times x times x.
All right. Now, look for those common ones.
So there's 2 2's. And then there's 3 x's.
GCF equals.
4x to the third.
Good job. You call this x cubed.
X cubed.
Now, LCM is going to equals. We copy down this guy first. And then, which one is left?
5.
There you go. Which one is left?
The 2 and the x, so 4x.
Good job. Equals.
4 times 5 equals 20 times 80. So
good.
And then 3x cubed times x is x to the 4th power.
Good job. Awesome. That's nice. This is good. This is beautiful. I like it. Very good. Let's look for some more complicated one, okay? 3. Let's do those 3 guys together, okay? Jason.
All right. 10 is 5 times 2.
Okay.
B times and then B times A.
Good. Next one.
20 is 5 times 2 times 2. And then times B and times A.
Okay.
28. 2 times 3 times.
Hey, hold on.
2.
2 times what?
Okay.
$28 is 4 by 7. So 4 is?
2 times 2.
Yes.
Times 7.
Okay.
Times
now
B
let's
times
highlight.
A.
Yeah, let's highlight.
2.
Yes.
B. A. And that's all the ones that we.
Yes. So we are going to put 2 and B and A times. This guy is?
5.
This guy is 5. This guy is also 5, right?
5.
Oh,
Yeah.
hold on. When it has 3 terms together, we have to watch out. If it just had 2 terms, the previous method works perfectly. If you have 3 terms, when these 2 have a guy in common, you can only pick one of them to be included, okay? So this 5 and this is 5. You will choose just one of them. You will pick just one of them. And this 2 and this 2, you will pick just one of them. Okay? And 7 you have to include. Okay?
Okay.
This give us a, go ahead.
So 10 times 7 is 70. 70 times 2 is 140. And then times B and times A.
There you go. Does this make sense?
Yes.
Okay. Yeah, let's try the number 26.
Okay, so 28 is 2 times 2 times 7 times B times B.
Okay.
And then for 20 is 2 times 2 times 5 times A times B times B times B. And then 16 is 2 times 2 times 2 times 2 times B times B times B times B.
Okay.
So there are 2 2's. There are two B's.
So the common factor, the greatest common factor is going to be
4B squared.
all right. So we extract 4b squares out of this first. And then we are going to check this 7 and 5a, b, and then 4b.
The 4B.
Okay.
Okay.
So let's take care of the number first.
So
This is 7 and 5 and 4. We have to include all of them, correct?
that's 140.
Okay, so this is going to be 7 times 5 times 4. Very good. Now, what else we have to include?
The A and the 2 B's.
A
Oh, the A
and the 2b here.
Yeah.
Yes? Very good. Yes, you made it. Very good. So this is going to be A and B and B. Okay, let's finish.
Okay, so 4 times 7 is 28 times
Look, this is 20.
20.
This is 140, right?
40. That's 140 times A and B squared.
Okay, equals
4 times 140 is 560
good job.
times A times B to the 4th power.
Very good. That's it. Yes, both of you great. Jason and Ian, you both go beyond my expectations. This is perfect. Okay, I will upload everything we have go through so far in the class. Before we end the class, is there any specific questions?
Was the amount of homework we got before the class going to be the norm, or that was just see how much we know?
Yeah, I'm going to, so the homework I'm going to upload today is going to be the same worksheet we have went through in the class, okay?
Okay.
I'm going to upload this kind of homework. I have the blank version. I will give you the blank version and the version with my notes, because I didn't go through all of them. So you need to drill those questions by yourself. But at the end, there is answer key for you to check your answer.
Okay.
You see what I mean? Yes.
Yeah,
So,
I know.
yeah. So this is everything we have been through today. So make sure you do your homework and upload to let your mom upload. And I'll see how well you've done it for the homework. And next week, we will go to this kind of equations, okay? I will teach both of you how do we solve those one variables equations. This is very important foundation, okay? So make sure finish this week homework and we will see you next week, okay?
Upload it.
Upload it to the Google Drive that your mom already make sure they already know where to access the homework. Okay.
Bye.
Okay.